Tuesday, September 7th. Our topic today is functions, how to identify. Who's heard of the word function before? Okay, and what kind of information do you recall from a function? Eden? Linear and nonlinear. Good. Addison?
Isn't it like something like fx, or did I just make that up?
No, that's right. Function of x. Yep, that's a familiar thing. We'll get there. What else about functions? Do you guys know how to determine if something is a function before you determine if it's linear or nonlinear?
No.
No?
Yeah.
Ish? Okay, so that's what we're going to focus on today, how to identify a function, right? So we have some vocabulary. First word is relation. And a relation is a set of ordered pairs. And then we've got this example here where we have these cool little brackets. Just do the best you can. And then I have these three ordered pairs here that are this is a relation because I have ordered pairs within brackets. So that lets everybody in the math world know. Yeah, that's a relation. You guys seen those brackets before? No? Ish, maybe? Grace? Okay. And then a function is a special type of relation where every input has only one output. Hopefully the words input and output are familiar. Ish?
No.
Kinda? Input, output. You guys remember like you had like a machine, like you put this in and something happens to it and this comes out?
There was like 2, 4, and then it could have been like 36 and 72. I don't know.
Yeah, like what did you do to it? Like it goes in one thing, comes out another.
Oh yeah, I never liked that.
Did you guys get to watch the metamorphosis video last year?
I did it online.
I don't remember.
Oh, we're watching it today.
What is?
Oh, it's a rite of passage.
What?
You're going to love it. Okay, we'll do that here at the end of class. All right, so we talked about input, output. So we're going to, in our vocabulary, we have an ordered pair, x, y, right? This is our ordered pair. Everybody knows what an ordered pair is. We have our x value and our y value. That should definitely be familiar. X is also known as the input, and y is the output. The x input can also be referred to as the domain, and the y output can also be referred to as the range. So we've got some synonyms here, right? We're talking about the same thing, just different words for it. So we're going to be looking at different relations, sets of ordered pairs, to determine if they are functions today. So is this relation a function based on, does every input have only one output? All right, so let's go ahead and ask ourselves, is it a function? It's going to be a fun game. So we have this super long relation, right? We have our set of ordered pairs. So does every input have only one output? So some of you are probably thinking, I have no idea what that means, right? I see some inputs, I see some outputs, I see some x's, I see some y's. So in super basic terms, our question is, do any x values repeat? Right? So does every input have only one output is the exact same thing as looking at this set of ordered pairs and seeing, do any x values repeat? Because if an x value repeats, that means it has more than one output, right? So when I look at these ordered pairs, do any of the first digits in the ordered pair repeat?
No.
Nope. So this is a function. So our answer would be yes. This is a function. Because no x values repeat. All of my y values repeat, when you're probably thinking that's weird, but that doesn't matter. We're going to kind of be ignoring the y values here for a bit. They don't help us determine, bless you, if something is a function or not. How are we feeling right now about determining if something is a function?
Pretty good.
Yeah? Don't worry, we're going to practice a lot. All right, let's go on to the next page. Are you guys good? Same date, so you don't have to write the date again. going to draw a table. Which is my x value? Input or output?
Input.
Input. Which makes y my output. So, is this a function?
No.
Why not?
Yeah.
How do you know, Kike? How do you know so quickly?
I don't know. It looks weird.
Well, okay, Brayden?
Is x repeats.
X repeats. So this is not a function. Because the x value 0 repeats. You could also say this is not a function because the input 0 has 2 outputs. Yes?
So say one of the inputs was like 1/2, and then the other one was like 3/6. Would that count as the same input?
Are you talking about like the
Like
ordered
if-
pair is 1/2 and then 3/6?
No. So like it's a fraction.
Oh.
Like the input's a fraction. And then
That would disqualify it, yes. Because if you simplify 3/6, you're going to get 1/2, right?
Yeah.
So we're going to get to it tomorrow, but imagine that these are like ordered pairs on a graph, right? If you go over to the same x, that's going to disqualify it, even if it's written in a different format, right? Even if it's a different, like, equivalent value. Mhm. Okay, another way to look at functions are through mappings. Did you guys learn about mappings last year? They're really cool. It's where you have this like ovally egg thing. So what I have here is just another way of showing ordered pairs, right? So these would be my ordered pairs on a table. These lines indicate, these arrows, this is my x, this is my y. So I would have the ordered pair -1, 4, 3, 15, and 11, 15. So is this a function? It is a function because none of these repeat. Remember, I don't care if the y value is used more than once. I just can't have the x value used more than once. So yes, this is a function. Because none of the inputs are connected to more than one output. Yes, Avery.
So it wouldn't be a function if it was like 3 went to 4, then 3 went to 15, and then 11 went to 15.
Correct. We're going to do that right now. We're going to show exactly what that would look like. So spoiler, this is not going to be a function. So like I said, this is a spoiler. This is not a function. What do you see happening here that disqualifies it? Jackson? Correct. Because the input 2 is connected to more than one output. As soon as an x value is used more than once, no bueno. So then, Eden, what we're going to end up doing in a couple days is determining, yes, we have a function, is it linear or not? And that's what you were talking about before, linear or nonlinear functions. So right now we're saying, is it a function or not? And then the ones that are functions, we're going to break down into linear and nonlinear, like a nice little family tree. You're fine. Okay, so that's what we're going to do for today in our notes. Now I'm going to find this amazing, life-changing video for you. Yep. Oh, you guys, this is so disturbing. You're going to love it.